Let's go check out this no heat situation here. Back room. I think our roof hatch is over here somewhere. All right, a little bit of an obstacle course, but not impossible. All right, so it looks like neither one of our units are heating properly. 64, 62. Let's see what our supply temperature is. Yeah. So this unit says the supply is 92. So maybe we have one unit not working. Maybe this unit's not working. And that unit's trying to heat the entire store by itself. Yeah, it looks to be the case. So this unit, our supply temperature is 50. They're not labeled, so we have one unit working, doing the work of two units. And that unit apparently is not doing the work of anything. I don't see anything tripped, nothing out of place here. Let's get up to the roof. There's our little blinky light that tells us what's going on. Let's see if we can actually see. Alright, so we got 6 flashes. Come over here. 6 flashes. Induced draft motor fault. Now our induced draft motor is running. I can feel it. There's no pressure switch on this system. What I'm going to do in this case is simply reset it. I'm going to cycle power off, turn it back on, and see what happens. This is actually a Hall effect sensor that's down inside my inducer motor. Now this Hall effect sensor, as far as I understand it, it is just a sensor that when it's exposed to a magnetic field, obviously when this motor's spinning, it generates a magnetic field. And when that Hall effect sensor is exposed to that magnetic field, it produces a signal. I'm not exactly sure what sort of signal it is producing. Well, I just got off the phone with a fine gentleman from Carrier Tech Support, and he gave me some pointers on testing this Hall effect sensor. First test we want to do is make sure there's no call for heat, so I removed my W1, W2 wires, and then you want to check these outer 2 pins for DC voltage. You want about, I think he said between 6 and 10. I got 10.3, so that's fine. And then the second portion of our test, we're going to plug the Hall effect sensor back in, and then we are going to go black to black and red to white. And then what we want to do is we want to slowly spin the inducer. Very slowly, we spin the inducer, and our DC voltage should change from less than 1 to 8. And it should do that back and forth, less than 1, 8, less than 1, and 8. Now, I am very carefully going to rotate my inducer motor and also try to hold this together. Alright, I am slowly spinning my inducer motor, and as you can tell, nothing is changing. So that means we have a bad Hall effect sensor. So I am just simply going to replace that entire inducer motor and be done with it. Alright guys, so we are at our working unit. There's the unit over there that we were just working on, the one with the bad Hall effect sensor. So what I'm going to do is I just want to test what tech support told me about this, just to see if it holds true. If I can do this. Careful, careful, there we go. Alright, so you keep an eye on my meter. I'm going to slowly rotate this motor. See, there we go. So it should go, as I spin it slowly, should go less than 1 to 8, less than 1 to 8, less than 1 to 8. See, less than 1, then I'll jump to 8, less than 1, jump to 8. So this one is good. I did check our heat exchanger, no major issues there. Our belt, however, is kind of loose. Not too terrible. Pulley's a little dirty. So what I'm going to do is, I've got a spare right here. This might be in decent condition. This belt's not too terrible though. It's not cracked or broken anywhere. So what I'll probably do is just drop the motor down a little bit, put a little bit of tension on here. No big deal. Alright guys, here's our new inducer motor, our capacitor. Got the zip ties all cut apart. We're going to go ahead and wire it in, bolt it down, and see if she fires up. Now I know I'm probably going to get a little bit of feedback about this. Now I know you can change, or I assume anyway, I'm going to pull this one off just to play around with it, but I assume you can change this Hall effect sensor all by itself, separate from the inducer motor. But I don't really feel comfortable changing just one part of a component. I guess in my opinion, if it's, even though the motor sounded good, you know, it was spinning at full speed, there was no other issue besides this Hall effect sensor, I just don't feel comfortable changing a part of a component. I'd rather just change the entire component, especially when we're dealing with a large account like this one is, and they don't really appreciate overtime calls, you know. So that's where I stand on that. There's our brand new inducer motor, our brand new capacitor. Come over here, got my belt nice and tight. I'm going to put that panel back on real quick, and then we are going to fire it up and see if she ignites. Because keep in mind, I wasn't able to test any of the ignition components, the sparker, flame sensor, gas valve, any of that, because yeah, obviously the ignition board isn't going to work until that inducer motor actually tells it that it's safe to ignite. So, but real quick before we get to that, I wanted to kind of show you guys this Hall effect sensor. It's much simpler than I thought. It looks like it is. So there's our little Hall effect sensor. So what it looks to be is right inside here. You can see where it's kind of a coated epoxy maybe or something that's in there. But I'm guessing that there's the actual Hall effect sensor is just molded inside of that. So as the motor spins, of course, this little wheel here, I guess, generates a magnetic field, and that's how it senses that the motor's actually going around, and it tells the board that it's okay to ignite. Seems like a fairly simple device, but this is literally the first time I've ever diagnosed one, so it's kind of nice to learn something today. All right, we have ignition. There we are. I got a supply of about 92. Our return air 60, 62. So we got about a 30-degree rise, which is normal. That does it for today. I hope you found this video somewhat somewhat educational or entertaining or something. Anyway, I hope you got something out of it. All right, we'll see you on the next one. Don't forget to hit that like and subscribe button for me. Go ahead and share this video if you know other people who like to watch cool stuff like you do. And yeah, give me a shout out on Facebook or Instagram, whatever. Thanks for watching, guys. I'll see you soon.